everybody. So yesterday I sent you guys some videos on Google Classroom through Edpuzzle about why things glow. Some glow in the dark things, some things that glow from ultraviolet radiation. And we've been talking about Bohr models and what electrons are doing. So what I want to do now is sort of combine those two ideas together. So we've been again talking about Bohr models. All right, so in Bohr models, we have our nucleus, our protons and neutrons are inside of there, and we have our electrons on our rings. And we said that the electrons, let me draw 3 rings here, follow a pattern of 288. 288. Right? And they're going to fill up one ring, right, before they move on to another. Let me change the color of my nucleus here so I don't get myself confused. There we go. Red's our nucleus. Right? So if we have something that has, let's say, 6 electrons, right, 2 are going to go on this first ring, and then my other 4 are going to go on the next one. 1, 2, 3, 4. Right? Because we said we can't move on to that third ring until the second ring is filled up with what would be 8 in this case. Same idea with our arrows. When we're doing the 1s2, okay? 2s, or sorry, 2 would be later. Right? We have to fill them up before I would go on then to like 2p. Okay? I wouldn't start going into 2p until I have 2s filled up. Then I could move into 2p. Right? That is going to be how electrons automatically arrange themselves. It's sort of just their default method of doing things. When they are in this sort of defaulted, expected organization, we say that electrons are in what is called their ground state. Okay? That is where they want to be. That is where they automatically will go, following the rules of they're going to fill up a certain section before they move on to the next one. Right? Just like if you were, filing into a movie theater and all of the seats were filled up in one row, guess what? You can't sit there. You have to move into the next one. Right? Same sort of idea. Now, there's some different things that can happen. Right? This is again what we call our ground state. But electrons are not always in this ground state. Sometimes they enter into what we call an excited state. They're excited, like we are because we love science. Wow, that's written really badly, I apologize. Okay, but excited state. Right, so what the excited state means is that these electrons are now not going to be where we expect them to be. They're going to move. Electrons are always moving, which you saw with your stop action video. Right, that they're moving around in their rings. But what happens sometimes, if they get enough energy, they can actually move to a higher ring. So we might have some electrons that move from this second ring out to a third ring. We might have some electrons here, maybe these down arrows, are going to move from an s orbital over to a p orbital. This is not what we would normally expect. This would be what we would say is wrong, right? But this can actually happen. And when certain things are exposed to light, this is what happens. So if you take glow-in-the-dark items, I have some little glow-in-the-dark tattoos here that my boys had for Halloween, right? These are right now in a ground state. Okay? If I would take a flashlight, where's my flashlight? Here it is. Okay? And I shine a flashlight onto these. I'm now putting the electrons that are inside of these glow-in-the-dark tattoos into what we call an excited state. What's happening now is these electrons are moving to outer shells and they are absorbing energy. So they're taking the energy from the light and using that to move. If I take this light away, okay, and turn off the lights in my garage, it's probably not gonna, oh, yep, it shows up there, whee! Okay, you can see my tattoos, obviously, are lit up. So what's happening now, right, these electrons that absorbed the light from my flashlight, now they're releasing that light. Okay, so they've absorbed the light, they entered into their excited state, and now that that light is gone, they're letting that energy go. They're working their way back to their ground state, back where we would expect them to be. But while they're doing that, now they're releasing light. Light is a form of energy. So the energy that they're releasing as they go back to their ground level is seen to us, right, as a form of light, our glow in the dark here. Right, so that is, let me turn my lights back on here. Sorry, that probably got really bright for you really fast. Right, so that is sort of the science behind why things glow in the dark. Right, and obviously related to what we've been doing here with Bohr models. Where we're going to be going with some more of this, now that we've seen that these electrons can actually move, okay, when we get into chapter 6, we're then going to see that these electrons not only can move within their own atom from ring to ring, they can actually move from one atom to another. And that's going to be our whole basis of chapter 6 and actually into chapter 7 also, looking at how electrons are going to be moving. All right, thank you for listening, everybody.